I guess everything has been said on the most important slide of the presentation. You can, tweet me. So I decided to talk about monitoring, and I think there are great ideas in Puppet. I know, obviously, otherwise I wouldn't be here. And I wanted to see whether they apply to monitoring, and if so, how we can make them work. So I'm going to start this little presentation with a simple question. Just kind of get the gut feel about whether you are happy with the monitoring you have, because I'm assuming everybody has some kind of monitoring in their shop. So simple show of hands, who feels that monitoring makes me happy and proud? Yeah. All right, so there's one hand in the back, or maybe 1.5. And the second group of people were people who think that monitoring really makes them cry and kind of want to hide. All right, I have a few more. So, that talk is for you guys. So what I basically want to see is I want to see monitoring become much better. I want to see, hopefully in a couple of years, people, when I say, does it make you happy? Are you proud of your monitoring? I want to see a lot more people raising their hands, because I think monitoring sucked for a long time, and it's about, it's high time it changed. So now why, monitoring, what's the relationship between Puppet and monitoring? So I would start with an assertion which I think everybody will agree with, which is that Puppet brings automation to system management. System administration, system management, however you want to call it. And so automation means that basically you don't have to do a lot of manual stuff and you save a lot of time. So my goal with this presentation is really to try to find ideas and instill the idea that we can improve monitoring the way Puppet has improved system management. And I think if we manage to do that, or if we're on the road to do that, then we'll have a lot more people who are happy about their monitoring. So I'm going to reminisce a little bit. So I'm going to think about the good old days before Puppet, and I say Puppet, and there are other classes of similar like configuration management software, but the good old days before Puppet is you had typically a configuration management database, which was an Excel spreadsheet, which had a list of all the machines that you had recorded at that time, and then what they were supposed to do, and then system administration consisted generally in SSHing in or telnetting in the really old days, and changing configuration by hand. Which obviously, so A is very error prone, but even that you can build controls, you can make sure that you do it, it's double checked by somebody else and so on. But the main problem with that approach was that it was so time consuming and used so much mental energy that you had a little time to think about anything else. So you were consumed with system administration was essentially a time-consuming job where you'd care about individual machine one after the other, and then it was really hard to see the big picture because there was always something to fix, always something to change. So then at some point, Puppet came. And what it did, which was, I think, why it became successful, is it basically gave us a language in which we could have rules, and we could express rules about what kind of results we want from, how we want our systems to be configured. So what kind of results we want to have. So for instance, if you had let's say you want to configure a fleet of web servers, then with Puppet now you have rules to say, this is my class of web servers, and let's say it's running nginx, and this is how you set up nginx on a given node, and then you apply, and magically, or not magically, but automatically it appears on all the machines that are classified as web nodes. So really, I think one of the key thing there is that it uses facts and classifiers to basically look at your entire infrastructure and decide, without you having to be involved, that this machine is a web server and it's nginx and so on and so forth. So in addition to cutting down the number of errors and leaving a machine out because it was not recorded in the main spreadsheet that had a list of all machines. The main thing that it did, it freed up a lot of time. And by freeing a lot of time, and it has a little asterisk here, it's on a per machine basis. By that I mean, with something like Puppet, you can obviously manage a lot more machine in a given 8-hour workday. But also importantly, it freed up a lot of our mental energy. So we didn't have to remember that this machine, there's a particular machine named XYZ that has some special parameters in its nginx because, and I know this and my colleague knows that, but it's sort of these folklore knowledge that got totally eliminated. Now you move to a clear description, clear rules. You express what you want your infrastructure to look like. You use Puppet for that, and then it applies and it works. And that's great. So one way you could characterize it is that Puppet basically brings immunity of configuration to change in infrastructure. You can add 20 more nginx machines. They'll be configured the same way the other, whatever, 50. So you can change the infrastructure. The result you're getting from it is not changing thanks to something like Puppet. Everything good so far? All right. Now, I have to say, this is not the first time a similar idea has been proposed, obviously. But good ideas apply to many domains, and that's essentially why I'm talking about Puppet and monitoring today. So going back to 1977, there's this guy called Christopher J. I forget what it stands for, but 1977 worked for IBM and said SQL brings immunity of application to change in storage structure and access strategy. So that was essentially the same idea. So it's about SQL, which I guess, let me see, 40 years from now, 40 years ago, IBM introduced System R, and they have this structured query language that basically says, instead of having to worry about how we get data from a system, we just have rules where we can express what kind of data I want. Very much like Puppet, as I'll show you. So in SQL, you have rules or queries that express what you want. They have facts and predicates, basically metadata about how, what data you're going to get back. And a result, at least in the early days, is that the introduction of SQL freed up a lot of time from developers because it let them, instead of focusing on how am I getting to get the data, it lets them focus on how I get the data. And that's essentially this. So here I have the very simple anatomy of a SQL query where it says, you select your desired facts, so the result that I want. You get it from existing facts, and then you apply some matching criteria, so where, this and this and that. And so with this simple query, you could completely detach yourself from the underlying storage mechanism. Much like with Puppet, you can completely detach yourself from the underlying infrastructure, or almost. So in Puppet, it looks, obviously very similar. It's very similar. At least I think you can translate the idea reasonably directly. So you move away from a very time-consuming imperative mess, which is to say, how do I configure my software, to something that's much more expressive. And you have configuration queries that says essentially, this is what it should be. This is not how I'm going to get there. So when you run a Puppet apply, for instance, you basically change to there's a desired set of facts that you want to establish, i.e., for instance, nginx is installed on this machine. And how do you get there? You just say, this is the result I want, and you're going to apply these rules based on existing facts, existing configuration, and then you'll just only apply to machines that have the right classes, basically. Am I making sense? Does this match your understanding of Puppet? All right, cool. So I'll take that as a yes. All right, cool, great, thank you. So as an example, if you want to deploy nginx, so you're on Puppet apply and you have all the classes set up. So the change is install the package if it's missing from the set of classes and manifests that define what a machine that runs nginx should be. And the facts are, the matching criteria, the filters are where the facts say that this is a machine where you can install nginx, and maybe you use ECN to classify it as a node, as a web node, and thus it'll apply the configuration to install nginx only on the machines where it should be. And of course, if you declare a new machine that fits the criteria that it should be a web machine, it'll get applied automatically. This is sort of, I guess Puppet 101, but I think worth recapping. So now, mentioned SQL 40 years ago, Puppet, I guess almost 10 years ago. Is there a pattern in this? And obviously, I think there is, and I'm trying to convey and hopefully convince you that there is. So to show that, I'm going to actually quote the overview, a paragraph from the overview of M Collective. So it says, M Collective essentially allows you to break free from ever more complex naming convention for host names as a means of identity. Use a very rich set of metadata provided by each machine to address them. By the way, who uses M Collective in the audience? All right, we have maybe 20% of people. As a quick recap, so M Collective is an orchestration system, and it's very much obviously tied with Puppet, and it allows you to apply, run commands on a large number of servers, based not on what names the servers have, but rather a collection of facts that the servers have. And so that's, if you will, a repetition of the same idea, where instead of kind of figuring out, doing a lot of time-consuming remembering this machine has that and that machine has that, and I have to run, I don't know, restart nginx on the machines that have a name of a certain class or a certain pattern, rather to a simple query where you say restart nginx on all the machines that belong to web pool A, for instance. So that's this little command, which I would call it a query almost, where you describe what you want to do and where you want to apply it, and you let the system figure out the rest. And this is exactly how you free up a lot of time and a lot of mental space, so you can think about the more important stuff. So following the same model, the same sort of descriptive model, we have basically the ability to say these are desired actions. So execute the desired action, which is in this case restart nginx from so existing Puppet facts and I'm sorry, I actually got it mixed up. So from Puppet classes, which is from all the machines that run nginx, and then where matching Puppet facts, which are, for instance, the fact that a given machine is part of web pool number A, not number, but web pool named A, for instance. So this completely abstracts you from having to remember that machine X is in web pool A. Puppet knows, and Collective knows. It's all encoded in facts, and then you can use a query to do all that. So that's a similar pattern, and hopefully I've been able to convey that there's a very similar idea across SQL, Puppet, M Collective, and it's always abstracting you away from detail so you can think about the important stuff. Now, let's go back to monitoring. So what I'm trying to say here is that I think monitoring is to behavior, as in infrastructure or system behavior, what Puppet is to configuration. Another way to say it is monitoring is to behavior what M Collective is to orchestration. So I'm really trying to, can we conceive of a monitoring system? Can we conceive of a way to monitor systems that borrows exactly the same idea, that has the same expressiveness, that frees up our time so that we don't have to spend a lot of it sort of in the weeds trying to figure out, oh yeah, this machine, it's a particular type of server, so it has to be monitored a certain way. That machine, it's another type of server, it has to be monitored another way. So really, if I'm trying to apply, again, the same pattern, from a monitoring standpoint, we got to move away from a time-consuming sort of imperative mess to something that's very expressive. So you say, all right, monitor. So I want my system to behave a certain way. So I want, for instance, web servers to respond under a certain amount of time. And the way the monitoring system can figure that out is you give it a bunch of metrics, a bunch of heartbeats, of system checks, service checks, and it'll filter that by Puppet facts, and then it'll verify that, say, the nginx servers in web pool A have the right behavior. I'm going to give you some examples because this is maybe a little bit abstract. So I'll actually dive into example. Now, so some examples, for instance, are something that I said, which is, and this is really how you want to think about monitoring. You don't want to think about is machine A up or machine XYZ up. You want to think about the thing I want to make sure is all my provisioned web servers in the production environment in a data center ABC respond to their queries under 200 milliseconds. And that's very close to how you express the value of the service. So you want to think in these terms. You don't want to think in machine A responds in 102 milliseconds, machine B responds to under 200 milliseconds, machine C responds under 200 milliseconds. Another example, for instance, is you want to say, well, all the Postgres servers must have a process called Postgres BG Writer running. So that's another way to express it. Or at least one active MQ is up to support mcollective. And so when I express monitoring like this, one thing that appears almost in negative is I never mention a host name. And it's interesting to see that, when you think about it, especially when you think about the way monitoring has been done in the past, I don't know, 5, 10 years, 20 years, hosts end up at the center of monitoring universe. So everything is indexed on hosts. And what I'm saying here is no, it's not. It should not be the case. Hosts are not at the center of monitoring universe. The facts are. So you want to, and by facts I mean really, literally Puppet facts. I mean property about hosts. That's how you want to express your monitoring. So that lets you do express that. So what are the facts here? The facts are this server is a web server, it's in the production environment, and it's a data center ABC. If a machine satisfies all three facts, all three criteria, then it should be monitored according to this particular paradigm. Now, it's not entirely, it's not an accident that hosts are historically at the center of the universe, of the monitoring universe, is because up until now, the infrastructure were relatively static, they were smaller, and because there were no tools like Puppet, anyway, it was hard to manage thousands and thousands of servers. So you kind of didn't need, monitoring could be very host-centric, and it kind of worked. It was not great, but it worked. But now it's over, because now we have cloud infrastructure that's tens of thousands of hosts, and there's just no way you're going to be able to monitor them unless you forget about host names. Much like there's no way you're going to be able to configure and manage 10,000 servers if you do it kind of in a host-centric way. If you don't use something like Puppet to apply classes, to have queries, and to have the same behavior based on facts, or apply certain behavior based on facts. So now you say, I say, well, yeah, this is all theoretical, whatever. I want to show you some examples to, show you what I mean, I guess. And for that, I'll use a sort of bad example and a good example. Let's think about, let's put hosts at the center of the universe, what I call AKA the wrong way. Now, the picture here is interesting because this is a representation of the universe before the Copernicus, basically. So when you look at the universe, which is the way naturally we're on Earth, everything rotates around Earth. You put Earth at the center of the universe, and then you try to adjust the reality to that model. And so what they did back in the day, when you put Earth in the middle of the universe, is to account for the planets and the stars moving, you have a very complex system of epicycles, so like circles inside circles, which made everything, astronomy, very, very complicated, especially with computers. So that's kind of how I see now, if you have a very host-centric monitoring, you're kind of trapped in that model. And that's back then, they spent so much time trying to account for these complex, so having to figure out the complex equations to describe the universe that you couldn't think of anything else, because it's a lot of complexity right there. So that's the analogy, historical analogy. Now, I'm going to use Nagios as an example to show you what it looks like when you have a very host-centric monitoring. So here's an extract. This is, I'm jesting a little bit, but this is an excerpt from the manual, the core manual on how to monitor cluster. So this is the preface to it, which is, it's fairly straightforward. So hopefully, you find things easy to understand. And by that, really, when they said that, when the person who wrote the manual wrote that, they basically prefaced this particular command, which lets you monitor a DNS cluster of 3 machines. So I don't know who uses Nagios in the audience. 1, 2, yeah, it's a good crowd. So you're familiar with its syntax. It's not exactly easy to figure out, but its syntax, you can learn it and you can automate it. Now, the interesting thing about this example, so it's a DNS cluster, and it's a cluster because really I don't care how many. I want to have multiple DNS servers. What I do care is I want DNS to work. If I have 10 servers and 5 out of commission, but DNS still works, I'm fine. I don't necessarily want to be alerted. So the way you do that with Nagios is you use this check service cluster, and you call it DNS cluster. Now, the interesting thing about this particular example is still you see the host pop up in the command. And so that's interesting because where did they come from? How do you figure out that the DNS cluster has these three hosts? So they're going to come from somewhere. So usually now, what you do is you have your Puppet manifest kind of compile this file, this template, and then plug these numbers there. But it doesn't feel natural. It's kind of an extra step. So the fundamental problem with the host-centric model is you cannot use facts directly. Is you always, whenever you want to describe your monitoring, you always have to go back to a host. So maybe you want to monitor all the machines, all the nginx servers in a given web pool in a given data center. You have to figure out which hosts they are and tell that to the monitoring system, because the monitoring system really only understands hosts. That's the basic construct. Now, you may say, for people who use Nagios, but it's fine. You can use host groups, or you can use service groups. And I'm saying, no, yes, you can. But let's say the problem is it blows up really quickly, and then your configuration file becomes huge, like a huge monstrosity with, literally, you can have easily, if you want to group hosts in certain ways, 100, in this case, 119 host groups, so different ways to group hosts together based on their facts. For instance, let's say you have 4 data centers, 5 classes, 3 environments. So sometimes you'll want to group hosts because you want to express your monitoring for all the machines that are in, say, US1, web machines in US1 in prod, that's one host group. Web machines in US2 in prod, that's the second host group, and so on and so forth. So you can easily see that, and 3 different dimensions, like just data center class environments, is nothing. This is really a trivial example. And that's already 100-ish host groups. So can you do it like this? Like, will it eventually work? Yes. Much like it's because it's like a Turing machine at the end of the day. You could say it like, yes, theoretically you can make it work, but practically, when you attack monitoring with a host-centric way, it turns into something that's very time-consuming. And I've used Nagios in the past, so this is how I used to do stuff as well, and it's not fun. Now, you may say, oh, but you have something against Nagios, right? So no, I don't. I still, I think it's a nice piece of software. But the problem, he has this flaw that he wants to see everything through a host. And sometimes a lot of what I want to monitor, I don't care where it runs. I don't care about the host. I just do care that the service works, DNS cluster. I care that I have enough DNS machines running. I don't care if it's machine A, B, or C, or machine B, C, or D, or D and F. I don't care. So I really, much like when you provision machines with Puppet, you don't really care about the machine you're provisioning. You just care that it's in a given class or has a couple of classes, and it has the behavior you want, and which piece of hardware is running. You don't really care. So it's not about bashing Nagios. It's just about saying host-centric monitoring is a tough proposition in today's world. Now, I am not necessarily the only guy saying it. So this I found from the Puppet Nagios author, who said, please note that this module, so the Puppet Nagios module, is not for the faint of heart. Even I, the author, have my head hurt each time I have to make modifications to it. So this is, you take it, you can take it with a grain of salt. But when you look at the module, you say, yeah, I can see why you're saying that. Now, the alternative approach is to put facts at the center of the universe. And this is now the right way. And here I'm representing, this is, I think, one of the earliest, it is either the original or a copy of Copernicus. So very different. It's hard to read, but the center says Sol, so the sun is at the center. And then you have the various planets. And you can see, obviously, very visibly that it looks like it's much easier, much cleaner. You don't have these epicycles crossing each other. And what that meant is not that it's easy to draw, but just that the mathematics to conceive heliocentric astronomy are a lot simpler than geocentric astronomy. And so what I'm trying to convey here is that having a fact-centric monitoring is the same thing. It's a lot simpler. So if I kind of go back to earlier examples, I have, I can say, I said one thing I may want to monitor is all provisioned web servers in production environment. In data center ABC must respond to web queries under 200 milliseconds, or all Postgres servers must have a given process, or at least one active enqueue host is here to serve and collective. So I'm going to use, for instance, a monitoring system that is much more fact-centric. So Sensu. Who uses Sensu here? All right, a couple of people. Two people, three. Well, good for you. So if you wanted to express, relatively simply, all Postgres server must have a Postgres BG writer process running, this is how you could declare it using the Sensu module. You just say, all right, so all the Postgres servers, I want you to subscribe to the Postgres channel, which essentially means I want you to say, hey, to the monitoring system, hey, I'm a Postgres server, and that's it. And that's all you have to say. The beauty of that is, all right, you write these 2 lines, and then things happen, and you don't have to worry about it. So obviously, when you do that, monitoring becomes it's a fact-based query, if you will. Is basically the system will figure out, well, is this node of the class Postgres, yes or no? And is it subscribed to the channel, yes or no? And if it's not Postgres, then move on. If it's Postgres but not subscribed, then subscribe it. And if it's already there, then fine. Let's just move on. So that's one example to try to show you what fact-based monitoring looks like. It's a lot simpler to conceive. It's a lot simpler to maintain. And you save yourself a lot of pain. So you can apply the same. I'm going to talk just very briefly about Datadog, which is the monitoring system I'm involved with. If you want to express, I want to monitor all my web servers in production environment in a data center ABC. So you install the module that sets up the Datadog agent, and then you just say, okay, this class, these are for the class. Set up the parameters Datadog agent and convert the Puppet facts so extract the Puppet facts data center and use them, and I'll show you how to use them. So once we do that, again, we express a query. So I want the nginx request latency for production, for all the machines that are in production, all the machines that have data center ABC to be less than 200, and you're done. Now, again, the beauty of this is that I don't know how many machines are in data center ABC in production, and frankly, I don't care. What I do care about is that they respond under 200 milliseconds. And I only want to be alerted when one of them is misbehaving. So what to take away from this, this talk? So fact-based monitoring really is, the first thing is hosts are not the center of the monitoring universe. If they still are, and it's going to be more and more painful because it's going to be more and more complex. So point number two is you want to think about monitoring not in terms of what hosts are doing, but you want to think of it as using queries, so much like the examples I've mentioned. And number three is these monitoring queries should basically integrate Puppet facts, because that's how you're going to have a nice system administration that's managed by Puppet, and then monitoring that's very closely tied to your system administration, so that if you grow your infrastructure, your monitoring grows with it. And that's it. Thank you very much. Any questions? All right, don't be shy. Does that resonate with, I don't know, with your experience? Do you guys are in violent agreement, violent disagreement with what I said? Okay. Oh, yeah, sorry.
So you showed an example of testing whether a system responds within 200 milliseconds.
Yeah.
That's just one of probably thousands of tests that we in the NAGIO school run. What other sorts of checks can you do with the systems at least you're using?
Right. So the question is, what kind of check? So describe, maybe give a few more examples on the kind of checks you can do with the fact-based monitoring. So you could do things like, I don't know. You want to make sure that so if you again look at latency of web distribution, you want to make sure that the outliers outside of 2 sigma from the mean are not within 300 milliseconds. Or you want to make sure that that's the case, but only for the machines that have a quad core and are running version 25 of the application, for instance. So the idea is you can use arbitrary facts, basically, to think about monitoring. So I mentioned class of machine. Data center is easy because that you can reproduce relatively simply. But if you're using maybe container-based infrastructure, it could be the name of the container. So there's no limit, basically. And the nice thing about it is that if you discover new facts or if you apply new facts to your nodes, you can use them. You don't have to. You can use them in your queries directly, and that's usually the case. Like you start with, with a class of facts, and then you extend beyond that. Yeah.
So this is very service-based, not necessarily host-based.
Yeah.
We do like to know when hosts go down.
Yeah. So
What's the mechanism for that?
so the question is, it's very service-based, and what do we do if you still care about hosts? So essentially, the way you can construe it is host is just an extra fact. The host name is an extra fact. And so you can specify monitoring based on host by saying the fact is host name is X, or host name is of the form X, Y, Z. But it doesn't have a particular significance. It's just a regular fact. Yeah.
That I'm paying for.
Yeah.
And if I'm monitoring just, if the node goes away, the facts go away unless they're exported.
Yeah.
Right? So how do I know that node went down? Does
So usually when you do that, you can have it, when it goes down, it can deregister itself and say, hey, I'm going away. So that's usually, because otherwise there's no way to tell if it's went away because you wanted it to go away or because it just crashed and then it disappeared. And I have a question, yep.
So on the other hand, if you want to say that, let me know if any of my web servers go down.
Yeah. Yeah, yeah, yeah. So in this case, so the question is, if you want to, instead of you want to be alerted if any of the web servers go away, yeah, you can do that. Because basically then you're saying, so monitor all the hosts and tell me if any goes away, or you could say monitor all the hosts and tell me if in aggregate, they behave a certain way. So you can either do any or all. I mean, you have, because these are essentially queries, so you can slice it and dice it the way you want. Happy to give you, by the way, more details after the talk if you want to see it in action. Cool? Anybody else? All right, well, thank you very much.